Question 6 in the Living Cert Higher Level 2019, we're told that x minus root 32 is equal to 128 minus 5x. Find the value of x in the form a root 2. So there's a clue in the question here, this root 2. You should know already from Surds that the square root of 32 is the square root of 16 by the square root of 2, which is 4 root 2. And the square root of 128 is the square root of 64 by the square root of 2, which is 8 root 2. So let's simplify it down using these two values. So bring the 5x across, we're going to get x plus 5x is equal to 8 root 2. And what are we bringing across? We're bringing across a minus 4 root 2, so plus 4 root 2. 6x is equal to 12 root 2's. Dividing by 6, x is equal to 2 root 2. You could also square each side, but I think this is probably the quickest and easiest way to do this question. In the second part of this question, we're told that set A is root 32k squared, root 50k squared, root 128k squared, and root 98k squared. So you should be able to see the relationship between these and the first part of the question. So root 32, we said already, was 4 root 2. So we know we can separate these surds into square root 32 by square root k squared. So this is 4 root 2 k. Root 50 is root 25 by root 2. So that's 5 root 2 k. Root 128 we said already was 8 root 2 k, and 249s are 98, so this one is 7 root 2 k. Now in a set where there's 4 numbers, the median is going to be the average of the middle two. So let's just put them in order. The 7 and the 8 are not in order, so 4 root 2, put the k in, 5 root 2 k, 7, we put them in order, 7 root 2 k, and 8 root 2 k. So the median of these two, we can see it's going to be 6, and the average, well, how many of them have we got? We've 4 plus 5 plus 7 plus 8, so we have 9 and 15 is 24 root 2 k's. So the average, if we divide by 4, is equal to 6 root 2 k. So we can say the mean is equal to the median. Part B of this question is the proof that root 2 is not a rational number. So what we do in our proof by contradiction is that we assume that root 2 is rational. And if it's rational, it can be written in the form P over Q, where P and Q have no common factors. So it's written in its simplest form. So we can write root 2 is equal to P over Q. So that means if we square both sides, we're going to get 2 is equal to P squared over Q squared. So 2Q squared is equal to P squared. And we know that twice any number is even, so P would have to be even. Let's just check that. If Q is 2, let's say Q is 2, we're going to get 2 by 4, which is 8, so even. And if Q is odd, if Q is 3, we'll get 2 by 9, which is 18, which is even. So that's twice any number. Obviously has a factor of 2, so it's going to be even. So therefore we can say that P squared is even. And looking at this one, 3 3s are 9. So an odd number squared will be odd, but an even number squared is even. So we can say then that P squared is even. So let's let P equal something that's even. So we can say P is equal to 2k. So now we can replace this P with 2k. So we'll end up getting to the fact that q is even. 2q squared is equal to 2k to be squared. So 2q squared will be 4k squared, and dividing by 2, q squared is equal to 2k squared. So similarly to above, to here, we can say that q is even based on the same maths. And similarly, we can say that q is equal to 2 times a number. We said p was 2k, so we just give it a different letter. We can say q equals, let's say, kl to lm. L looks a bit like a 1. So p over q from above, from the very beginning, root 2 is equal to p over q. Root 2 is equal to p over q, which we now have changed into 2k over 2m. And you can see that these have a common factor of 2. So common factor. Therefore, by contradiction, we can say that root 2 is not rational.